Am I alive? I guess I am. So let's start with solving these questions. Okay, Okay, I don't know how much time we have. It's 5:42, so maybe we'll do it for 10 minutes. Then we'll have a workout for 45 minutes. Athletic work. You ain't coming? No, no, no. Where the frick is my pen? I swear on this. I don't know. There's showing me some guidelines on YouTube about not being able to swear. Whatever. Let's start. We'll solve these part two questions. Which era? 2022, 2023. Okay, let's go. Back to 0.5 by 6. 1 by 2 into 1 by 6. 1 by 12, comma. We have 0.2 by 8. That is 1 by 5 into 1 by 8, 1 by 40. Okay. B is 0.5 by 2. It's 0.5 is 1 by 2, 1 by 4, and 0.4 by 4. Let's calculate it. It's 2 by 25. 2 by 20, that is 1 by 10. And 0.1 by 6, 1 by 10, 1 by 60. 9 by 10, 9 by 80, whatever. So how do we solve this? We need to find A union B. Four elements, it has four elements. So union basically means the max of element. I mean the max of first element, a max of member set. Whatever. So you need to make these denominators same, right? Now here you can multiply. Right. You can just put 4 and 4 here. Okay, and intersection is minimum. Then we have the complement. Complement of A would be 1 minus of A. I mean 1 minus A is will give the complement. and b's complement would be 1 minus b. So 1 minus every membership will basically give you the complement. Then we can find out the intersection, which is min, and the union, which is max. Easy. What is ANN? ANN is artificial neural network. Artificial neural network. It's this similar structure of neural network in our brain. Then I don't know how to explain it more. It has an input layer and the middleware layer. We have the input layer, middle layer, which basically computes everything, and the output layer. No, for sending and receiving back data. And how is it different from a biological? And then, yes, they have certain math functions that are being used, but we have that natural computational ability, the artificial neural network. Uh, Definitely look this up. By look this up, I mean put this in freaking chat GPT. Because these things are good questions. If you read it, you can understand it very well. And AI has been a lot of help in this. You can understand a lot of things using AI. So, an artificial neural network is a computational model inspired by the structure and function of human. Okay, called artificial neurons, which work together to learn patterns from data. Mm, to find patterns from data. That's one of the uses. Good. Okay, those they work similarly to our brains. Like our brain uses the experiences we have to find certain patterns. Artificial neural networks also do the same. We have weights and experience. Oh, okay. So the artificial neural network, the signals are transmitted through the numeric values, and in our brain, it's transmitted through this. So brain will learn through a synaptic plasticity. Plasticity. We need to understand that term. What is synapticity? But for the better or the worse, let's just skip for now. Of course, and we did put up that our brain automatically through experience, but ANNs need training data and algorithms to learn. Hmm. What is self-organizing map and is coherence map? Self-organizing map. That's the basic you should be asking. Oh, self-organizing. Coherence map. Clustering and visualization of high dimension. Just pause it. for a second. Oh, there's no option to pause. Okay, you guys have to wait. Okay, let's continue. So self-organizing map, also known as, it is an unsupervised neural network used for clustering and visualization of high-dimensional data. Mm, okay, it basically works like the reproductive system when a male sperm enters the female's ovulatory system. What happens is there's a competition between the neurons, and the winner neuron gets updated with best matching unit along with its neighbors. This performs self-organization, clustering, and feature mapping without labeled data. Algorithm of Okay, so the Cohen's algorithm initialize weight, input selection, input vector from the training data set, find the best matching unit, update the vector of mu and its neighbor, ensuring the learning rate and neighborhood, fine tuning. Okay, these are the features: unsupervised learning, topological preservation, dimensionality reduction. So we need to understand two things. What is topology, map, learning rate, neighborhood radius, geometric arrangement of neurons, self-organizing map. Okay, so connected in basically grids. Map is a two-dimensional grid of neurons. Learning rate is the learning rate on how much they are registered during training. Neighborhood radius. Okay. So, um, so what did we learn? We'll write this question later. Okay, let's do some points. It's the unsupervised neural network. It basically converts the high dimensional HD into 2D and puts some weight in it, some numeric value, the compute, and it takes input, now the computation of neurons for what is best. Then we have, hmm, I'm so sleepy. In fact, my head is spinning so freaking much. It's ridiculous. The computation of neurons for what is best, okay? And it sends the data, updates data, decrease learning rate, and decrease neighborhood radius. Features we can write doesn't decrease topology and ah, unsupervised learning, dimensional reduction, competitive learning, cluster formation. It's a sketch explains the training and testing of recurrent neural network. So a recurrent neural network would basically mean it's an unsupervised neural network which will send the data over and over again for fine tuning and yeah, for fine tuning of the data. That's what I think. Let's see. That's true. I need to write this thing. RNN, recurrent neural network is RNN. Okay. Neural network. I think the next stage it's input, then output. Take some input data, find some output, and from its formula, from its pattern structure, test against expected output, and fine tune it. Okay. We have the input layer, the hidden layer 1, hidden layer 2, and the output layer. So what happens? I don't know. So Yeah, basically just add the output. It's fed back into the input layer. The network remembers past information using hidden layer, enabling it to learn temporal dependencies, training of RNN. Okay, the input sequence feeding where we feed the input, then it goes through the input hidden layer where it finds the data, and there is the output calculation, then the loss calculation, then we use the back propagation. We found an interesting thing, back propagation, back propagation method. Okay, interesting. And we update the weights. Yeah, that's cool. Okay, what is this? Define and discuss mathematical extension principle of a mathematical extension principle. I don't know what that is. Find b equals to what? Okay, I'm hungry. Hmm. Okay, it's a lot of mathematical values. Fuck this, I'm gonna do it another time. A neuron with three inputs has the weight vector W equals to 0. Its binary sig model and the output of the neuron. We ain't doing numericals for now. If I had one more day, at least, I could have gone hard on this, but still, you should be happy with what you are given. You should not be greedy. Type of religion. Takagi versus Sugeno fuzzy architecture. Okay, so let's understand what is the Takagi fuzzy architecture. And let's say Takagi Sugeno. Specified using number set functions. The instance of each rule is computed using operators and product domain. Each of the crisp output from the linear function. Oh my god, I'm so sleepy. Okay, well, let's do this question. Explain the various phases of genetic algorithmic control in nonlinear time delay system. I'll be back. I need some coffee.